Okay, in this video, we will try to prove odd even identities. That is, we need to know why sine of minus negative angle, why minus sine theta is same as minus sine theta, and why cosine of minus theta is plus cosine theta. Okay, now consider an angle. So we have consider a unit circle, which you see right here, and this radius is 1. So I'll pick initial side from the origin. Let's consider this uh, initial side from this. uh, Consider this one from here. This is the original side. And then let's take terminal side as this one with some angle. So because this is a unit circle, this one will have some coordinates. So So that's why this will be x, and y. Now remember, if this is the angle theta, let's take it positive. Theta is positive, theta is greater than 0, maybe 30 degrees, 40 degrees, whatever. So that's theta. Now this angle, how we do define cosine theta? So cosine theta by definition is the x coordinate of the terminal point, which is x here, right? And sine theta is by definition is y. Okay. Now let's clone this pink color. Let's clone this, take it back there, and rotate it clockwise direction. So this from here to here is theta. That could be 40 or 50, whatever. Now I'm gonna go to in the clockwise direction. This magnitude same, but in the clockwise direction. So this will be the theta, but the negative. So this side, let me write this will be, this is minus theta. So then how the coordinates will be done? This xy, so this xy will be, so cosine of minus theta. So this in the fourth quadrant, it's minus x and plus y, correct? So when you write the definition, cosine of the angle minus theta is, by definition, it is the x coordinate, and that is minus x. I made a slight mistake here. Let me take this. This is x is, this is positive and the second one is negative. So let me take this off. So this is x and negative y. So this answer will be cosine of minus t, right? So this is cosine and that is sine, right? So this is x, but then x is, we do know x is already takes cosine theta. So this is cosine theta. Okay. The same thing is also sine of minus theta is the y coordinate, and here it is. This is minus, instead of y, it is minus y. So it is minus y, and replace back what is, so get sine minus sine theta. So what did we learn from here is, so here you get, so this is uh, sine minus theta is minus sine theta and cosine. So what did we learn is sine of minus theta is minus sine theta, and cosine of minus theta is is cosine theta. We can also write this. This means it is even cosecant of minus theta will be minus cosecant theta, and this one will be secant of minus theta will be secant theta. So the negative sign vanishes. But when you write tan of t minus theta, definition of tan is y over x, right? So the y coordinate, if you see this in the fourth quadrant, it is minus y over x, and that is equal to minus y over x. And by definition, this is minus tan theta. So even for tan theta, this minus is pulled out. And the same thing is cotangent of minus theta is minus cotangent theta. So these are called odd odd even identities. So this is all I wanted to show because and in the so why are they called odd even is because if you graph the cosine function, cosine, let's see, if I want to graph cosine, the graph of cosine is this way, right? So this starts from 0 until here is 2 pi. That means any point, let's see, if if this is 60, so 60 is half, so this is 60 is half. And this side also, minus 60 also is the same y coordinate half. So it doesn't matter, right? So they have the same thing. But if you take, that's why this is called, this one is a even function. So cosine function is an even function because it is reflective, it is symmetrical about the y-axis, and the sine graph is this one, see, 2 pi, and the other side it goes this side. That means if I take 30 here, and sine of 30 is half, right? And the same thing, sine of minus 30 is minus half. So if this is 30 is half, this side is minus 30 is minus half. And that's why sine is odd function. In other words, if there is a point xy on the graph, then also minus x minus y also lies on the graph. Also, the definition of odd function is if you have f of minus x is minus of f of x is the definition, and you can clearly see that sine of minus theta is same as minus sine theta. So sine is odd function or symmetrical about the origin. See? So whatever is goes this side is the same this side. So symmetrical about the origin. Hope that helps, and thank you for watching. Just wanted to show the odd even identities.